myself Aditya Narayan Thakur. I am from UP. We are the student of Weltech Technical University, Avdi, Chennai. Today we are going to talk about our project. We are the final year student, BTech final year student. So we are going to talk about our project. So our project title is Soft Computing Technique for MPPT in PV application using ripple current orientation. This is my project mate, Mr. Alok Kumar Misra and Mr. Amritesh Kumar Rai.
चालू हो जाइए.
We are doing this project under the guidance of our internal guide is Dr. P. Chandrasekhar, who is the Triple E HOD of Weltech Technical University, and our external guide is Dr. B. Subramanian, who is the director of ECA. And now I am going to talk about our project abstract. So in this project, to implement the maximum power point tracking for fuzzy controller in MPPT method was implemented based on the voltage and current reference of PV value was obtained from a PV module. And we are using in here the fuzzy controller is used to directly control the design of a DC to DC cup converter. In this project, the tracking system. In this project, the tracking of the maximum power point tracking plays an important role in PV volatility application for power system. So we are going to talk about our block diagram. So this is our PV panel. This is our PV module. It is connecting with our converter, and in this is our PV module. This PV module is going to connect with the phase detection circuit with MPPT. In this block, it is inbuilt with MPPT technique. There are two types of MPPT. First one is direct method and second one is indirect method. So we are going to do through the indirect method. So we are using here observation and perturbation. We are using here the algorithm of MPPT, perturbation and observation. After this, this two line is going to connect with PWM generator with microcontroller. In this PWM modulator, it is inbuilt with PWM generator with the PIC microcontroller. So it is going to connect with a gate driver circuit. The gate driver circuit will derive and it will generate the pulses. After generating the pulses, the pulse will go to the cup converter. The cup converter will send some power and it will send the power to filter. Our filter work is store the power and it will directly give to the application. This is our proposed block diagram system in our project, which we have used in our project.
Start.
Now I am going to discuss about our simulation part. So this is our simulation part. We are going to talk about our simulation part. In this simulation part, this is the PV module. This whole block is called as PV module. In this, here T is the temperature and S is the whole part is called as deriver part. This whole part is called as deriver part. So in this from the subsystem the supply is going to connect with this system, and it is going to connect with resistor, inductor and capacitor. Through this, between inductor and capacitor, one line is going to connect with IGBT, and the IGBT is directly connecting with the this controller part. Through this, here from the subsystem, one input is going to here, and through this system one line is going to connect with this operator part. This part is we can call as comparator. This whole part is we can call it as comparator. It's working principle like a comparator. That's why we can say this is called as comparator. Here we have dumped our fuzzy logic. In this project we have dumped all the fuzzy logic or coding here in this block, and this is our pulse generator. Through the fuzzy logic controller, the pulse will generated with the pulse generator, and directly it will go to the IGBT. Through the IGBT, one diode will connected and one inductor will connected through this diode. So here this is our MOSFET. This is our inverter. It is made up of four MOSFET. In this PWM generator will connected, and it will directly give output. This scope is giving a output for AC. This probe, this scope will give a output for AC, and this is our DC output. This is our DC output probe or scope, and this is our PWM generating output. Through this, there are four indication is given here. First for one MOSFET, second for second MOSFET, and third for third MOSFET, and four for four MOSFET. Because in this inverter we are using four MOSFET. That's why here it is indicating by four lines, four arrows. So this is the PWM generator output. This is our whole part of simulation. This is the output. I'm going to show the output. This is our output. This is our output of PWM generator. This is our AC scope output. Because see, it is going negative, after that it is going positive, after that negative and positive continuously. So this we can call as our this is current output. And again, now we are going to see about our DC current. Now we are going to see about our DC current output. This is our DC current output. Because see, it is Initially it is starting from 0 and it is tracking. It is tracking the power through MPPT, which we have dumped in our circuit, in our software, and it is going to track, and continuously it is tracking the ripple current, and it is going up to a peak level. So this is our DC output. This is our DC scope output. Now I am going to show about our microcontroller, sorry, PWM generator output. So this scope will show the output of PWM generator. This is our PWM generator output. This is our PWM generator output. That's all. This is my simulation part, and we have seen all the output. That's all. After this, I am going to talk about our hardware kit. This whole thing is our hardware part. This is PV module. The specification of this module is 30 watt. In this circuit we need 12 volt supply. That's why we require a 30 watt PV panel. So this is our PV module, and this is multimeter for checking purpose, for testing purpose. The output voltage, the output power and input power, we are using the multimeter. This is our application, and the specification of our application is, this is 230 volt and 15 watt. This application needs load 230 volt 15 watt, and this is DC batteries we are using for our microcontroller, because this controlling unit needs 5 volt supply. That's why we are using this 9 volt batteries. So in this is our input part. It is coming supply from this PV module, and is connecting this equipment, and through this it is going to give a supply to our transformer. This transformer is a step up transformer. Because we are using a step up transformer here? Because in step up transformer there are more than the turns is having in this transformer, more than the turns through the more than the turns having in this transformer from primary to secondary winding. That's why we are using